we're going to create functions that will delete a node from anywhere in the doubly linked list. And I'll simplify the code for the functions using some animation so that you're able to visualize and most importantly to understand how the code works. I will show you the code and explain it as we continue to build our doubly linked list project. In this video, I will show you how to delete a node from different positions in a doubly linked list. It is very easy, and after this video, you will be able to write the delete node functions for our doubly linked list project. In this video, we will cover deleting a node from at the front, at the back, and at an index in a doubly linked list. And after I show you what the code does using some animation, I will show you the complete code for the functions in our doubly linked list project in this video. So after this video, I will upload a video on reversing a doubly linked list. So I strongly suggest that you click the bell icon next to the subscribe button so that you don't miss this video and other data structures videos or other programming content that I'll upload. And also click the subscribe button if you haven't already, and welcome to ACoreFundamentals. The goal of this video is to create three functions. The first one will delete a node at the head or front of a doubly linked list. The second one will delete a node at the back of a doubly linked list. And the last one, which takes in an index as an argument or the position where we want to delete the node, will delete the node at that position. The first function we will look at is the one that deletes a node at the head or front of a doubly linked list, and this is the easiest. So we'll create a del front function, meaning to delete a node at the front, and this function will only call another function, del front1, which takes in a head node pointer of the doubly linked list, and this function will do the actual deleting of the node. So the del front1 function is also a void function and takes in a node pointer as an argument, and we will create another pointer which we will use to point to the node we want to delete, and we'll call it the del pointer. It's a node pointer, that's why we use node star before we declare it. And we'll check our first condition. The if statement will check if the head node pointer is not pointing to null, or if we have nodes in our doubly linked list. And if we do, then we enter the if statement and we set the deletion pointer to the head node pointer. Then we set the head node pointer to point to the next node, which is ptr next. Remember that then the head node pointer was passed in as an argument to the second function, so ptr is also pointing to the head node. So ptr next means the node after the head node. Now we have the head node pointer pointing to the second node and the del pointer pointing to the first node, which is the node we want to delete. And now we point the current head node previous pointer to point to null, disconnecting the node we want to delete from the doubly linked list. And now we can delete the del pointer, and then we delete the del pointer. The else statement of the function would have been executed if there were no nodes in the doubly linked list. And so we can move on to the next function. And for the function that will delete a node at the back of a doubly linked list, we will create a function called del back, which means deleting a node at the back of a doubly linked list. This is also a void function and does not take any parameters. This function will only call another function, del back1, which takes in the head node pointer as an argument, and this function will do the actual deleting of the node. Let's look at del back1. This function is also a void function and it takes in a node pointer, and ptr is also pointing at the head node since the head node pointer was passed in as an argument to the second function. For this function, we will declare two more node pointers, the deletion pointer del ptr, which will point to the node we want to delete, and another node pointer which we'll call prev ptr. We want this node pointer to be one step behind del ptr, so we have access to the node before the one we want to delete. So we set the pointer del ptr equal to the pointer ptr. Remember, ptr is pointing at the head node, and that's where we want to start. The if statement will check if the head is not pointing to null, and if we have nodes in our doubly linked list, we enter the if statement and we have a while loop which will run until we find a node with its next pointer pointing to null, and that node will be the last node in the doubly linked list, which is the node we want to delete. And since the head node next pointer is not pointing to null, we will point the pointer prev ptr to del pointer and advance the del pointer to the current del pointer's next pointer, which is pointing to the next node. And the second node's next pointer is not null, so we're still in the while loop, and we point the prev pointer to del ptr and advance del ptr to the next node. And the third node's next pointer is also not null, so we're still in the while loop. We point the prev pointer to del ptr and advance the del pointer to the next node. Now the del pointer is pointing to the fourth node, and its next node pointer is pointing to null, so we exit the while loop. The prev pointer is pointing at the third node, so we set its next node pointer to null, disconnecting the fourth node from the doubly linked list. And finally we delete the deletion point, the del ptr pointer. And the else part of the code would have been called if we did not have nodes in the doubly linked list. Now for the last function, the function that will delete a node at an index or a specific position in the doubly linked list. We will create a void function called del node, which takes in an index or the position of the node we want to delete. This function will call another function, del node1, which takes in an index value and the head node pointer of the doubly linked list. Let's look at the del node1 function. It's also a void function and takes in an index and a node pointer. For this function we need two node pointers, the del ptr and the prev pointer. This time we also need an integer counter variable x and initialize it to 1, because 1 is the first position or the first node. The if statement will check if we have any nodes in the doubly linked list, and if we have nodes like we do in this example, we will get to the while loop, which will run until the counter is equal to the index passed in, and that will mean we have arrived at the node we want. And since we want a node at index 3 or position 3 and the counter is equal to 1, we are in the while loop. We point the prev pointer to the del ptr and advance the del ptr to point to the next node and increment the counter by 1. The counter is now 2, but the index value we're looking for is 3, so we're still in the while loop, and then we set the prev pointer to point to del ptr and advance the del pointer to point to the next node and increment the counter by 1. Now the counter is equal to 3, and so is the index we're looking for. Currently the prev pointer is pointing to the second node and the del ptr is pointing to the third node, which is the node we want. The first statement after the while loop will set the previous pointer's next pointer to the deletion's pointer's next pointer, and then set the previous pointer of the node after the node we want to delete to point to the previous pointer pointing at the node with the value of 3, meaning we're connecting the second node to the fourth node. And finally delete del ptr. Now let's look at these functions in the project files where we'll compile and run the code and test how they work. Now back in our project files, for deleting a node in a doubly linked list, we need to create a few functions, and in our doubly linked list.ccp file, this is where we'll define these functions. But first we need to define the function prototypes for those functions inside the header file. So the first function will be the function that will delete a node from the front. And this is a void and it takes no parameters. And the second one will delete a node at the back. And the third one will delete a node at a specific position inside a doubly linked list, or we'll just call it an index. And this function will take in an integer index value of the node where we want to delete. And in the private section of the class, we'll define the first del front1 function, and it takes in a node pointer. And then we'll define the del node back1, also takes in a pointer. And finally, the del node 1, which takes in a pointer, and it also takes in an integer index value and a node pointer. And now we can continue to define these functions. Now, the del front function will only call the del back1, passing in the head node pointer as an argument. Now for the del front1 function, which takes in a node pointer, okay, we're first gonna check if the head pointer is pointing to null. That will mean the doubly linked list is empty. But if the head is not pointing to null, we actually want to do something. The first thing we need a pointer, del pointer, which will hold the node we want to delete. Now we want to set the del pointer equal to the head node, because that's where we'll start. And then we'll set the head node to the next node. And then we want to delete the del pointer. And that's it. Oh, we want to set the previous pointer of the new head node to point to null. And that's about it. Now deleting a node at the back of a doubly linked list. The del back function will only call the del back1 function. These are from the class doubly linked list. Okay, so this will call the del back1 function, passing in the head node pointer as an argument. Okay, now the del back1 function takes in a node pointer as an argument, and we want to create a deletion pointer. And then we check our first statement. If the head pointer is pointing to null, then the doubly linked list is empty, so we cannot delete anything. But if we have nodes in our doubly linked list, then we're able to delete a node at the back. So the first thing, we want to create a while loop, which will find the last node in the doubly linked list. So we'll continue to advance the PTR pointer to point to the next node until we find the last node. And we need another pointer we'll call temp. It's a temporary pointer, and we want to keep the temporary pointer one step behind the pointer PTR, so we have access to the previous node. But I think this will work just fine. So after we find the node, the last node, we want to set the deletion pointer equal to the node, so we're pointing to it. And then we want to set the previous pointer of that node to null, so we're disconnecting the last node from the doubly linked list. I think we actually need that pointer, temp pointer. So that we disconnect the next pointer of the node before the last node from the last node, so that we completely disconnect the last node from the doubly linked list. And then we can just delete the deletion pointer with the last node. And that's how we delete a node at the back. Now, deleting a node at a specific position or an index. The delete the del node function takes in an integer index value, and it only calls the del node 1, passing in the index and the head node pointer as arguments. Now let's look at the del node 1 function. It's also from the linked list class. Okay. Now del node 1 takes an integer index and a node pointer. Okay, for this function, we first need to check if the head node pointer is not pointing to null, making sure that we actually have nodes in the doubly linked list. And if we have nodes in the doubly linked list, we want to check if the index is valid. So if the index is less than 1, or if the index is greater than the size of the doubly linked list plus 1, that would mean the index is outside the range of this doubly linked list. And I've just realized that we need to update the size variable as we delete the nodes. Okay. So if the index value is outside this range, then we want to print out a message to the user. But if we have a valid index, then we can search for the node that we want to delete. I need a pointer, the previous pointer, and another node pointer called the next pointer, and another one called temp pointer. We might need these, and an integer index counter, an integer counter variable called x, set it equals to 0. Okay, so we'll create a while loop. If our counter is not equal to the index we're looking for, we want to set the previous pointer equal to the pointer ptr, and then want to advance the pointer ptr to point to the next node. So we need to ptr next. Okay, and then we want to increment our counter variable. And then we want to set the next pointer of the previous node to point to the node. We actually want to set I need a deletion point here. Okay, we want to set it will be okay, we want to set the deletion pointer equal to ptr, which is the node we want to delete, and we want to set the next point of the previous node to point to the node after the node we want to delete. Okay, and then we want to set the next point of the node we want, okay, the previous pointer of the node after the node we want to delete to point to our previous node, which should fix that. And then I think now we can delete the deletion pointer. Yeah, now we can delete the del pointer, deleting the node we want to delete. Okay, now in our main.tcp file we will test the functions we just created to check if we have any errors. Okay, so we want to call the del front deletion function, want to call the del front function, and then print our resulting linked list. They actually want to print out message deleting nodes before we actually delete these nodes. Okay, let's run our program. and it seems like we have an error. So we need to go back to the main.ccp file and check where the back one or the pointer the star, we need node star. Okay, and have another error. Go back one, null pointer. Oh, it should be a small letter p. Let's run. Okay, we don't have any errors now. Let's run the executable. And you can see that the node at the front, which was 1, has been deleted. Now let's try another function, deleting at the back. And I'm just gonna copy that function, compile the code, and then run the executable, and then you can see that 9 has been deleted, which was the node at the back of a doubly linked list. Now let's delete a node at an index 1, and this should delete 5. Okay, download pressing in index 1, and okay, need to check if, and remember this is assuming that our index is starting from 0. Oh, I didn't have any errors, it didn't compile the code. But yeah, 5 has been deleted from the doubly linked list. And now that we have functions to delete a node from a doubly linked list, we can move on to discuss reversing a doubly linked list, and I'll be discussing the reverse doubly linked list function and showing you the code. And please take only just 10 seconds to click the subscribe button, because it helps me to grow this channel. And while you're there, just turn on notifications so you don't miss any videos that might help you in the near future. Like this video down below and share this video if you found it helpful and interesting. Thanks for staying with me until now, and you can support me by checking out my Patreon page. I'll leave the link in the description. And welcome to ACoreFundamentals.